Have you ever wondered how Netflix constantly ships features without ever breaking anything, or how Amazon scales on Black Friday without melting down? Well, the answer is simple. It's microservices. So today I'm going to explain what actually are microservices and how they're built in the real world. So startups usually begin with a monolith, all features in one code base and in one database. Now that's great at the beginning, easy to deploy, easy to reason about, but as teams and features grow, you hit problems. You get slow builds, risky releases, code conflicts, and one bug can take down the entire app. Now a microservices architecture splits a large application into small independent services. Each service does one job well, has its own data, and communicates with other services via well-defined APIs. Think of a restaurant. You've got the bar, the kitchen, the bakery, delivery. Each has its own team with their own tools and responsibilities. So they coordinate, but they don't share the same stove. So what does a service actually include? Well, a service isn't just code. It's a domain boundary with a clearly defined business capability. It includes an API, or the application programming interface, which is a set of rules that allow these services to communicate with each other, kind of like a messenger that facilitates data exchange between applications. It also includes data with its own database tables or database. A service can also be shipped without coordinating with every other team. It also includes observability with its own logs, metrics, and tracing. And as for its ownership, only a small team is responsible for its end-to-end. Now, when you split an application into services, they need to communicate or coordinate, and services coordinate in two ways. You will use both. We've got asynchronous calls and synchronous calls. Now, synchronous calls are request response. One service calls another service and waits. The common forms are HTTP REST, which is easy to integrate and inspect, and we've got gRPC, which is a compact, strongly typed RPC that is efficient for internal service-to-service traffic. Now we use synchronous calls when the result is required now. For example, checkout calls for payments to authorize a card, but the trade-off is coupling to latency and availability. If payment is slow, checkout feels slow, and if it's down, checkout fails. But you mitigate that with timeouts, retries with backoff, and circuit breakers, so you fail fast and degrade gracefully. Now, asynchronous messaging decouples producers and consumers. For example, a service publishes an event, let's say, for example, order placed. So this event is published to a queue or topic, and subscribers like notifications and analytics consume it later. So we use asynchronous when work doesn't need to block the user. Now, why do teams choose microservices? Well, with this architecture, you can deploy one piece at a time instead of deploying one big bang release. You also scale only the hot parts like search or checkout or whatever is busy. Also, a fault in one part is less likely to take everything down. And also, teams can pick the right tool for each slice. Of course, obviously the downside here is that you've got more moving parts to run and observe, and that's the cost of flexibility and speed. So, should you use microservices right now? Well, if you're small, you start with a modular monolith, one code base with clear internal boundaries. And when a part becomes the bottleneck, for example, it deploys too slow or needs different scaling, you extract just that piece into its own service, and you grow as the pain grows. Now that's it for today's video. I hope everything was clear. Hit that like and subscribe buttons, and if you have any questions, drop them in the comments below. And if you want to check my cloud and IT courses, you can check the link in the description below. I'll see you in the next video.